Hi there, this is Dr. C. Sonia, Assistant Professor in Chemistry, SNS College of Technology. In this video, we're going to see about uh, the explosive temperature and the ignition temperature of a fuel. So this ignition temperature, it plays a very important role in fuels. So we can just go through the slides. So what is this ignition temperature? It's actually defined as the lowest temperature to which the fuel must be heated so that it starts burning smoothly. So this is the first process for the fuel to burn. So it defines as the lowest temperature to which the fuel must be heated. So the ignition temperature of coal is about 300 degrees centigrade. In the case of liquid fuels, the ignition temperature is called the flash point. Okay, so this flash point, it ranges from some 200 to 450 degrees centigrades. For the gaseous fuels, the ignition temperature is in the order of 800 degrees centigrades. So for the liquid fuels, it is less compared to that of the gaseous fuels. What is spontaneous ignition temperature? In this context, we are interested to know about the spontaneous ignition temperature. It is the minimum temperature at which the fuel catches fire, that is, it ignites spontaneously without external heating. If the ignition temperature of a fuel is low, it can catch fire very quickly. On the other hand, if the ignition temperature is high, it is difficult to ignite the fuel. If the heat evolved in a system is unable to escape, temperature of the system goes on increasing, and when the spontaneous ignition temperature is reached, the system burns on its own. Okay, so without giving the ignition temperature, initial temperature for burning of the fuel, if the temperature system is going to increase spontaneously, then the system burns on its own. So there's something called explosive range or the limits of inflammability. So explosive range is an important term that we have to concern. That is, all gaseous fuels have two limits called the upper limit and the lower limit. These limits represent the percentage by volume of the fuel present in the fuel air mixture. Lower limit represents the smallest proportion of the combustible gas. Upper limit represents the largest proportion of combustible gas. The range covered by these limits is termed as the explosive range of the fuels. So, for the continuous burning, the amount of fuel present in the fuel air mixture should not go below the lower limit or above the lower limit. So, if it is going to cross a barrier, that is the crossing of the limits of inflammability. So, explosive range of the petrol is 2 to 4.5. This means that when the concentration of the petrol vapor in the petrol air mixture is between 2 and 4.5 by volume, the mixture will burn on ignition. When the concentration of the petrol vapor in the petrol air mixture is below 2%, that is the lower limit, or above 4.5%, that is the upper limit by volume, the mixture will not burn on ignition. Some of the limits of the inflammability is given in the table as hydrogen. The lower limit of inflammability is 4. Upper limit of inflammability is 74. In the case of acetylene, the lower limit of the inflammability is 3 and the upper limit of the inflammability is 80. For the natural gas, the lower limit of the inflammability is 5 and the upper limit of the inflammability is 14. So these are the different explosive range for the fuels, gaseous fuels that we are using. Thank you.